Okay, I want to go back over the use of range in a definite loop to create outcome in two different ways. So write loops to produce the following output using two versions of range. Our desired output is going to be 18, 14, 10, 6, 2. The first problem I want to do is using range n. The second one I want to do is using range n, comma m, comma o. So over here, the n is, this range will start at 0 and go up to, but not including the final number n. Over here, we're giving a start value, a stop value, up to, but not including that stop value, and then what are the increments that we're going to use. So we'll start off with this A on the left. Desired output is 18, 14, 10, 6, and 2 using range n. So the n here represents how many times the loop is going to run. So in our problem, n is going to be 1, 2, 3, 4, 5. So n equals 5. And our for loop will be for I in range n. So I is going to run over the numbers 0 through 4. And we want our output to be 18, 14, 10, 6, and 2. And then what we're going to do is we're going to print the linear function here that depends on I that we're going to figure out from our table. So in our table, we're going to imagine this is like our x and this is our y. And we're going to find our slope, which is the change in y over the change in x. And if the increments are not the same, this isn't going to work. But we notice in this loop that as I increases by 1 each time, or as x increases by 1, the output is decreasing by 4. So -4, those are 4s. And our slope then is -4 over 1, or m is equal to -4. The reason this is nice is because when I don't want range n here, I want range 5. We just identified that n was 5. So for I in range 5, my slope is -4, and we're going to get this equation for our output is equal to the slope m times x, but here x is I, and then plus the y-intercept, which is our b value. So in this problem, my slope is, color here, -4. So our output's going to be oh, that's weird. -4. Sorry. Just wanted to switch colors. -4 for my slope, I, and then plus the y-intercept. But when I is 0, you get your y-intercept, so plus 18. And this is the thing that we want to print. Print -4 times I plus 18. So I'm going to switch over to Python and just type that in real quick. I've already opened up a module. So I defined it as loops.py, its name. I put my name in the class. I declined to put a date. I described the problem. We use two versions of range, indefinite loops to produce the output 18, 14, 10, 6, and 2. We always want a main function. And down below, we can invoke main at the end of the module. Okay, so our first one is A. I'm going to indent here, and I'm going to say use range n. This is problem A. And essentially, we've done it already for I in range 5. So that we had to figure out there were 5 things that we're going to print. And then we're going to print -4 space times I want to use the spaces between my operators, the times, and then plus space 18. And then that should be good to go. So I'm going to run it. It's going to ask if I want to save it, or I need to save it first. So we'll save it. Say, okay, it's called loops.py. So I'll just save it to my desktop. Loops. If you need to pause to fill in the comments or whatever, you can do that. And there's my loops. I check it, 18, 14, 10, 6, and 2. We're good to go. I'm gonna go ahead and set up here for part B. We're gonna use range, but now we're gonna have a start, a stop, and a increment, how much we're gonna go by. So I'm gonna go back to this other thing over here. And change pages here. So now I want to use range n comma m comma o. So, what does this mean? This means we are using range. It's the start value followed by the stop value followed by the increment, how much you're going to go by. And in this case, we're going to say for I don't have to do that yet. So for our code, the start value is whatever we're starting with, and that here is 18. The stop value, we go down to, but don't include. So it has to be something lower than 2, and it could be 1 or 0 or -1 or even -2. And we can test those in a minute, but I would say go down to, but don't include 1. Just 1 below that. So we're going to go down to, but not include 1. And then the increment is how much we're going down each time. And we are going down by 4, or an increment of -4. So that loop just looks like this. For I in range, start at 18, go down to, but don't include 1, and go by -4s. And now we're actually just printing I. So in some ways, this feels easier. It is a little easier to figure out because in the other example, we had to find the slope, which was -4, and the 18 was our start value. But in this problem, what's harder to see is that we don't get to see how many times this loop is going to run. If you look back at the other example, when we do it, we can see the loop's going to run 5 times. So from a coding perspective, I think this is a little bit more transparent. But from, let me just do the quick and easy, this is maybe a little easier to figure out. Okay, so I'm going to open up Python again. And we'll go in here to part B. And so we're using a range with the 3 parameters. Those are the functions that are going in that range function, or the parameters going to range. For I in range, we're going to start at 18. We're going to go down to, but not include 1. And we're going to go by -4s. Oops, I need a colon there. And I know that I needed it because when I hit return, I didn't indent. So, or when I hit enter, it didn't indent. So my colon, then I will automatically indent. And in this example, it's easier. We're just printing I. I'm going to run it. It should run twice. Oh, let's put a blank. Sometimes it'd be nice to put a blank print statement in here. So we print an empty line between the 2 outputs. Here we go. Save it. My first output, 18 down to 2. My second output, 18 down to 2. And I want to just show you, I could decrease this one. I could decrease it down to actually -2 if I wanted to, because it's, even though -2 would be the next number that prints, the code's going to go down to, but not include that number. So notice it still stopped here at 2. If I went one further to -3, that would be wrong, because that would then print that extra number of -2. We don't want to do that. So we'll go back. I suggest we just leave it 1 lower than what we want, which is, and then we're done. So again, both those versions will work. We want to know how to do both. I think, like I said before, that the first version is maybe a little stronger in terms of the next person who comes along who reads this code. This is easier to look at and see what's going on than this is. But from our perspective, if you just want to code it out and get that output, sometimes this might be easier to do the computations on. Okay.